All right, so this little video is for the problem 4 from the exam on planetary orbits, ellipses. And notice what I'm saying here. Watch my video first as I'm doing part E for you. So let's look at part E. In the posted Excel sheet, click on the E&A tab, enter one set of values for eccentricity E and semi-major axis A in astronomical units, not kilometers, for just one more planet. Look these values up for Ceres or Jupiter or Saturn, Uranus or Neptune or Pluto. So I'm going to do that. I chose Pluto, and I'm going to scroll down here to show you these here. So that's the best image of Pluto, actually. There was a satellite or a spacecraft called New Horizons flying by about 4 years ago, and that took these images of Pluto. So now we know how the planet looks, how its surface looks like. Okay, here are the semi-major axis, so 39.482 astronomical units. 1 astronomical unit is the average distance between Earth and Sun. So that means that Pluto is approximately 39 times further out from the Sun than the Earth, so quite a bit, of course. And then this is the eccentricity, 0.2488. The eccentricity tells us two things. One of them is how elliptical the orbit is, and you will see actually at this number here, 0.2488, which is quite large compared to other planets. It's actually still almost circular. You will see that. But the other thing it's also going to tell us is how far is the focus or the foci from the center of the ellipse. That's, of course, where the Sun is in one of those foci. All right, so I'm going to take these two numbers, 0.2488 and 39.482, and I'm going to go to Excel. And I have it already prepped. You can see it here. So I'm going to take these two numbers, and as soon as I plug them in here, you will see that over here, numbers will be calculated. Right there. There we go. By the way, I said the 0.2488 is relatively large compared to other planets, and you can see that all of these here have 0.0 something for the eccentricity, which means their orbits are virtually circular. The only exception being Mercury, but even that has it still looks circular, and it's just a little bit more oval than the others. Okay, now the numbers that I do need are actually these here, the 39.482, the 38.240, and then there is one little bit off here, and that is the focus here, 9.818. So that means that the Sun is actually quite a bit away from the center of Pluto's ellipse. I think I already copied that into Desmos, so now I have to remember these other two here. I think I know how I'm going to do that. I'm going to push this window here to the side so I can look at it at the same time. Go over to Desmos. Here are the planet orbits of the inner solar system, and again we can see they're virtually circular, right? Yes, their center is a little bit off because that's where the Sun is. It's not in the center, it's in the focus. Over here on the side, this is where I'm going to plug in the numbers. Oops. So this is where I need to plug in the numbers for Pluto. As I said, I already plugged in the 9.818, but here this one is a 39.482. So 39.482. And over here, this one is a 38.24048. I don't think I need to have it that accurate, but oh well. This one here I have to fix 9.818. And then here I'm going to put in Pluto. And now when I go to this diagram, and here's the inner solar system, I'm going to scroll out. I have to zoom out a long ways in order to actually figure out where the orbit is. Okay, my Pluto orbit is actually a little bit, I think I used the wrong number here. Should be, how much is that? 39.48, maybe. Or maybe it's the other one. Sorry about that. All right, there it is. And here we can see Pluto's orbit. And I mean, it's huge compared to the inner solar system, but notice as what it claims it's elliptical, it's still pretty darn circular. You have to look really, really close. This one here is approximately 30. This one here is approximately 50. So that's a total of 80 across here. But notice here in the vertical, we have close to 40 and close to 40, so it's a little bit less than 80. So maybe it's a total of 75 in the vertical here, so to say. And here it's just about 80. And you have to look really close in order to figure out that it's actually a slightly elliptic orbit. And that's actually it for part E. And turns out for part G as well. And turns out for part F as well, the equation, because it's written right here. The one is a little bit off the screen. There you go.